Okay, problem 1, it's improper integrals. Why it's called improper integrals? Okay, because you can see when x is 0, lowing 0 is not defined. Okay, so to avoid that situation, we should use a limit to substitute this 0, right? So this improper integration should equal to limit t is approaching 0 from the right, because it's between 0 and 1, right? So t should be approach 0 from the right. The integration from t to 1. Okay, so you can see these two are very similar. Okay, these two are the same thing. Then x ln x. But if you're writing this way, this t will never be 0. So this integration actually is meaningful. Okay, so let's just do this. So the limit. Okay. So because I don't want to copy limit every time, so I will just do this part first. So from t to 1, x ln x dx. Right? Use integration by parts. So this part is your u prime, this part is your v. Okay, so it should be half x squared ln x from t to 1 minus the integration from t to 1, use u times v's derivative. Right, so it's half 1 squared times ln 1 minus half t squared times ln t. Okay, minus this integration from t to 1. Right, so here ln 1 is 0, it's negative this minus 1 over 6 x cubed, right, from t to 1. Sorry, a little mistake here. It should be x, so here it should be 1 over 4 x squared. Right, which means it is this. Now, the only thing you have to do is to find the limit of this part. Right, limit t approach 0 from the right. Okay, you can see this part it's approaching 0, but ln t is approaching negative infinity. So what can you do? You can use the L'Hopital's rule, right? You can use the L'Hopital's rule. So this part is 0, this part is negative 1 over 4. So it's negative 1 over 4 minus half, right? So just put ln t on top and put t square, right? You put 1 over t square on bottom. Okay. So because this top is approaching negative infinity, the bottom is also approaching positive infinity, right? So you can use the L'Hopital's rule. You differentiate top, it's 1 over t. You differentiate bottom, it's negative 2 times t to the power of negative. Right. So this is okay. This is t squared. anyways, when t is approaching 0, it's approaching 0, so the answer is negative 1/4. Okay, that's why finally your integration from 0 to 1, x log x, is negative 1/4. Okay, so right, the first step is to write the integration as the limit, the improper integration as a limit of a proper integration. Then you do the proper integration first. Okay, then you find out its limit. Okay. So part B, from 0 to 1. For r over square root of 1 minus r to the power 4. You can see when r is 1, right, the bottom is 0. This function is not defined. So it should be limit t is approaching 1 from the left, because it's from 0, 1, right? So t should approach 1 from the left. For r over 1 minus r to the power 4 dr. Right, then you use one-time substitution. Use u equals r squared, right, which means du over dr is 2r. Okay, so use one-time substitution. Its limit t is approaching 1 from the left. Okay, so u is r squared. So r is 0, u is 0. R is t, u is t squared. Okay, 4r times r, it is 2u. 2 du, right? 2 du. And the bottom is square root of 1 minus u squared. Okay, for this we know what it is. Right? So these parts, integration 1 over square root of 1 minus u squared, it's sine inverse u, right? For u from 0 to t squared. So it's 2 limit t is approaching 1 inverse sine inverse t squared. Right, sine inverse 0 is 0, so that part disappears. So now when t is approaching 1, right, so you can sub in, right, 2 times sine inverse 1, which is 2 times half pi. Right, because sine half pi is 1. So the answer is pi. Okay, part C, from 1 to infinity, x to the power of negative 3 dx. Okay, obviously when x is infinity, this thing is not defined, right? So it's a limit t is approaching positive infinity from 1 to t, x to the power of negative 3. Alright, so it's x to the power of negative 2 times 1 over negative 2, right, from 1 to t. So it's a limit t is approaching infinity right, t to the power of negative 2 plus half. Okay, so when t is approaching positive infinity, this thing approaches 0. Right, so the answer is 1 over 2. Part D, from 5 to infinity, 1 over square root of x minus 1. So again, it's a limit of t approaching infinity, 5 to t, right? 1 over square root of x minus 1. Okay, this part, what is the integration? This part is x minus 1 to the power of negative half. So the integration should be x minus 1 to the power of positive half times 2. From 5 to t, and let t approach infinity. So its limit to t minus 1 half minus 2. Right, when you sub 5 in, it's 2 times 2. But anyways, when t is approaching infinity, this part is approaching infinity. Right, because the power is half, so it doesn't matter. So the answer is infinity. Okay, which means this improper integral diverges. Okay, previously from a to c we have a value, so the answer is the improper integral converges. Okay, here when it's infinity or negative infinity, it means it diverges. Okay, part E. From 2 to infinity, this. Right. So its limit t approaching infinity from 2 to t, 1 over x ln x squared dx. Okay, use the substitution, u equals ln x, so du over dx is 1 over x. Okay, which means it's ln 2 ln t, okay, 1 over u squared du. Right. So it's negative 1 over u from ln 2 to ln t. Okay, so it's negative 1 over ln t plus 1 over ln 2. Okay, as you can see, when t is approaching infinity, this is approaching 0. Right, so the answer is 1 over ln 2.